If you're feeling lost and unsure what to do to pass GED math, then know that this video is for you. Now, I know that you'd probably rather be doing something else right now besides sitting here studying math, but I really appreciate your time, and I'm really hoping that this GED math study guide is going to be what you need to help you get the knowledge and move ahead with math so you can get the test behind you and go on to whatever's coming next for you in life, whether it's college or a better job. And I'm going to help you do that by giving you the knowledge you need to know in this video and in the other two videos in this series. If you're coming over here from part 1 in my study guide series, then welcome back. If you missed part 1, don't worry about it. You can start right here, right now with part 2, and I'll put a link down below to part 1 if you'd like to go back and watch it. And if you're new here to my channel, this is Test Prep Champions. My name's Parker, and I live in Minneapolis right now with my wife. Now, we just had a baby a few months ago, so sorry in advance if you hear any crying in the background of this video. We also have a cat named Tommy who often makes guest appearances here in my videos. We're going to start off by looking at counting techniques, and I should add that all of these topics is all coming right out of the GED Testing Service official study guide, so I'll put a link to that down below, but we're working off of that today. And we're starting off with counting techniques, and we're going to look at one example problem provided by the GED testing service for each of these topics here. And the second topic is probability. Now, I do have a probability video on my channel where I talk about probability more in depth, so if after you try this practice problem for probability, if you're still confused and feel like you need some more work on it, you can check out that video if you'd like to. And we're then going to look at adding, subtracting, multiplying and factoring linear expressions, and then algebraic expressions, particularly how to deal with translating words and text into math symbols and vice versa. And we're also going to look at adding, subtracting, multiplying, dividing, and factoring polynomials. Again, this is another topic. I have a whole video on dividing polynomials. I've talked about factoring on my channel before too and other places. We're going to look at one key example of this, but like many topics here, there's videos that cover some of the stuff more in depth in my channel. And then we're going to look at creating polynomials to represent problem situations or word to symbol translations. And I know some of this stuff sounds like gibberish, but I'm just reading this off of the study guide. If you want, you can make kind of a checklist for yourself with these topics, but it's totally up to you. The next topic we're going to look at is addition, subtraction, multiplication, and dividing rational expressions. And we're going to then look at writing an expression from a written description. We're then going to use linear equations to solve real-world problems, and then we're going to solve a system of two linear equations. This is a topic that a lot of people have trouble with, so if you've had trouble with this in the past, hopefully this, when you see the example of how to do this, hopefully that's going to really help make it stick for you. And then we're going to also look at solving inequalities and graph the answer on a number line. Well, actually, you'll see when we get to this point in the video, the example that they give really doesn't, I don't think, touch on this skill that much, so this might be something that you might want to look at some additional stuff with inequalities and number lines after this video if you want to. Totally up to you. It's probably not going to make or break your score, but I don't think that the example that they give for this really deals with inequalities and graphs, so up to you, but we're going to get started right now with the practice problems. Okay, so the first question says, a restaurant serves custom-made omelets where guests select meat, cheese, and vegetables to be added to their omelet. There are 6 vegetables available, and guests may select any 2 vegetables for their omelet. How many different combinations of 2 vegetables are possible? So I will say here on the GED study guide that I'm working off of in the video, they don't provide this formula for you. So I'm going to give this formula to you right now up front, though, just to help you with this question. Because if you don't know how to use this formula, you might be here all day trying to figure this out, and we don't want to have you do that. But just know that the formula, it's n exclamation divided by r exclamation parenthesis n minus r parenthesis exclamation. Now, if you don't know what the exclamations mean, probably not going to be able to get the right answer. But just so you know, here I put the notes n equals total number of objects in the set. R equals the number of choosing objects from the set. So I'd like you to pause the video, try this out, and if you haven't studied combinations yet or practiced any of that, even with the formula here, it might not be that helpful if you're not sure what you're doing with the formula. That's perfectly okay, don't worry about it. You're going to learn how to do it, but I'd like you to try this out, and regardless of whether you get it right or not, we're going to go over it. Okay, so let's go over this. So like I said, combinations are kind of, they seem harder than they are. Maybe, but this question here, it gives you this hint. It says how many different combinations, which is a clue that you'll want to use the combination formula. I mean, if you want to try to draw a diagram and try to figure this all out like some other way, you might be able to do that, but it's probably just going to take up a whole lot of time. You might not get the right answer, so that's why we have this combination formula. And we know that n is the total number of objects in the set, which it would be 6. Okay, n is equal to 6, but it's not just 6. So this is the part where if you haven't studied combinations yet, you might not have known to do this. And like I said, you know, we're not here to make anybody feel bad or here to, you know, make anyone feel bad for not knowing something. We're just here to show you how to do it right so you can maximize your score. But you might not have known to do this. And what you have to do is when you see, so this is what we call, it's not just n, it's called n factorial. And that's just a fancy way of saying, you know, you take the 6 and you have to also multiply all the numbers smaller than 6. So you do 6 times 5 times 4 times 3 times 2, and also technically it's times 1, but it doesn't, I don't always even write the 1 because it kind of wastes time to write it, because 1 times any number is just going to be that same number. So now we go downstairs, let's look at the denominator of our fraction. Denominator is everything in the bottom part of the fraction. R is going to be 2 here, all right? And it's not just R, it's not just 2, it's going to be 2 factorial, meaning we would do 2 times 1. But I'm not going to write the times 1 here just because I don't think it's just going to take up a little bit more time to do it, because 2 times 1 is just 2 anyway. So the next part of the formula is parenthesis n minus r factorial. So what this means is I want to take my n, which is 6, and I want to subtract by, oops, what am I putting 4 here? I want to subtract by 2. Okay, so this is a 2. Just pretend that this is 2. So I know this is probably hard to read, but it's 6 minus 2, which is going to give us 4. So that's where I got that 4 from. And so again, it's n minus r factorial. So it's not just going to be 2 times 4. It's really 2 times 4 times 3 times 2 times 1. But again, I'm not going to write the times 1 because there's not really a reason to. So now all we have to do is we're just going to, you can run this in your calculator, and what you'll get, and I calculated this out beforehand, you have 720, right? If you do 6 times 5 times 4 times 3 times 2, you get 720. Then the bottom part here, you're going to get 48. All right, because you'd want to technically start with what's inside the parentheses, so you do 4 times 3 times 2, which is 24, times the 2, which is 48. So 720 divided by 48 is 15, and 15 is the correct answer here. All right, so just remember, you know, if you see this word combination, you'll want to use this combinations formula. They might not tell you it's a combinations problem. You might have to figure that part out on your own, but in this case, they did tell you it's a combination, so we're just going to roll with that here. And you just have to know how to use this formula here, and just remember, just because you figure out what n is, like in this case, n is 6, it's not just 6, it's 6 times 5 times 4 times 3 times 2. Times 1. Okay, the next question says, in a shipment of toys from a manufacturer, the probability that a toy is defective is 1 over 50. If Marie selects 2 toys from a shipment, what is the probability that both toys are defective? So I'd like you to pause the video and, as always, try this out, and then we'll go over it. Okay, so in this question here, what we have to know is that the probability of one toy being defective is told to us that it's 1 over 50. And so for 2 toys now, all we would have to do is multiply 1 over 50 times 1 over 50, right? Since it's the probability of one toy being defective is 1 over 50, we need to figure it out for 2 toys, so we just multiply the probabilities together, and the answer is D. So hopefully that makes sense here. I have a whole video about probability. You know, I rehash different cases and scenarios, but to get this one right, here's how you do it. D is the right answer. Okay, so this question says subtract parenthesis 3x minus 4y parenthesis minus parenthesis 4x minus 3y parentheses. A is negative x minus y, B is 7x minus y, C is negative x minus 7y, and D is 7x minus 7y. And I want to read this out just so it's clear what you're being asked to do and clear what's going on in the question. So as always, I'd like you to pause the video, try this out, and then we'll go over it. Okay, so the first key skill here that you really have to understand to get this right is that because there are parentheses here, this minus sign gets distributed. Now, I know your next question, for at least somebody out there, is thinking, what does distributed mean? Well, let me show you what it means. So basically, whoops, why did this happen? Don't know what's going on with my screen. But basically what we're going to do here is we're going to rewrite this so that it becomes 3x minus 4y. That's going to stay the same. That's not going to be changed here. And this 4x is going to become minus 4x. All right, that's the first big thing you need to see. But what about here we have 4x minus 3y. Well, again, we're going to distribute this multiplication sign. So, or we're going to distribute this minus sign, I mean. So we've got minus times minus gives us a plus. So this becomes plus 3y. So that's really the big key here to getting this question right, is you have to understand how this minus sign is going to be distributed. And we will essentially rewrite this as minus 4x plus 3y. So that's the first key thing you have to understand here for this question. The second key thing is that we want to work with what are called like terms. So you have 3x minus 4y. You really can't do anything because the x and the y are what we would call unlike terms. They're different things. That's like you've got, 3 apples and 4 oranges. You can't subtract apples from oranges type of deal right there. But basically what we're doing here is we need to see that there's 3x right here and that this is minus 4x right here. And that's what we have to work with, all right? And then we're going to do the same thing with the y's. So basically you can kind of think of this, it's just 3 minus 4 here. Okay, it's just 3 minus 4. And if you have trouble conceptualizing how to work with negative numbers or just with subtraction or addition in general, I think it's always helpful to just always refer to a number line when needed. You can just think of this in your head, but basically we've got 3 and we want to take away 4. All right, and we know here that 3 is a bigger I'm sorry, 3 is a smaller number than 4. All right, so if we've got 3 things and we take away 4, what happens? Well, start at the 3, we'd go 1 step, we'd go 2 steps, we'd go 3 steps to 0, we'd have to go 1 other step here, which would get us to negative 1. So 3 minus 4 is negative 1. So since it's x's here, it would be negative x. Okay, and now on the other hand, we want to work with our y's. So we got our x's out of the road, now we want to work with our y's here. And so we've got minus or negative 4y plus 3y. All right, so you can think of this really the same way here. So let's start with negative 4, right, because it's negative 4y. So on a number line, we'd have negative 4, negative 3, negative 2, negative 1, and 0. And of course, you could always just put this in the calculator, but the bigger picture here is, number 1, I want you to understand kind of how to read a number line and just kind of conceptually understanding what's happening when you've got minus 4 and you're adding 3 to it, okay? Of course, you can do this in your calculator. In fact, many of you probably already know the answer to minus 4 plus 3, but I just want to explain it here so we really get the concept for those that are struggling with this. So on a number line, if we start with minus 4 and we add 3, you can really kind of think of it this way. And sometimes I like to draw a stick figure. Sometimes it helps, sometimes it's just kind of a waste of time to draw it out. But I think people have commented before and said, oh, I really liked your stick figure drawing, so sometimes I do it. I think it helps. You can look at my drawing and how bad it is, and it helps you remember it better, hopefully. But basically, we want to take 4 steps. So we start at negative 4, we go 1 step, then we go 2 steps, and we go 3 steps. And we know that we're going this way, we're walking this way because we're starting at negative 4 and we're adding 3. So addition, we're getting to a bigger number, all right, because negative 1 is bigger than negative 4. That's another thing sometimes I think people have trouble conceptualizing, because usually, you would think, well, 4 is a bigger number than 1. But it's the opposite with negatives. Negative 4 is a smaller number than negative 1. But anyway, the answer here to that part would be it's going to be minus 1, or in this case, minus 1y. And you don't really write minus 1y. I mean, you could, but it's not typically how it's going to be written. But the answer here is A, and so I hope that this explanation makes sense. Again, you could always just, if you have trouble, just do that in your calculator, but you're not going to always have a calculator on the test here. And this kind of question, You might get a question like this where you can use the calculator, but I would say this type of thing is also fair game for the no calculator portion. And so I just know sometimes people get confused when they try to do like a 3 minus 4 or vice versa, -4 plus 3, things like that. So always think of the number line if you have to do something like that in your head and you're just confused about how to go about it. Okay, the next question says, in a science experiment, the initial temperature was 55 degrees Fahrenheit, and each hour after, the temperature dropped by 4 degrees. There we go, all fixed. Which expression represents the temperature in degrees Fahrenheit after T hours? So I'd like you to pause the video, try this out, and then, as always, we'll go over it. Okay, so basically for this question here, this is just kind of an example of translating words and what you see into math terms, basically. So it says the initial temperature was 55. So the word initial is kind of a clue that, not only is that what the starting temperature was, but sometimes when you see something like the initial temperature was this, in your problem solving, you might want to start with that 55. So the initial temperature was 55. As a general rule of thumb, when they tell you something like that, that's also a good place to start with your problem solving. So I'm going to start by just writing 55 here. And it tells us that in each hour after, the temperature drops by 4 degrees. So let's just think about it in terms of 1 hour. So if we're just talking about 1 hour here, how would you figure out the temperature? Well, if the initial temperature is 55 and then 1 hour later the temperature decreased by 4, you would think of it in terms of, well, 55 minus 4 would be 51, all right? But it's not just 1 hour here, right? They're just telling us, each hour after that, the temperature dropped 4 degrees, but they don't tell us how many hours. We have no clue how many hours. And so it just tells us to find, which expression represents the temperature in degrees Fahrenheit after T hours. So if it was just 1 hour, it would just be 55 minus 4, and that would solve the problem. Since we don't know what the hours are, how many hours there are, it could be 1,000, it could be 1, it could be 2, it could be 3. We put in T, and whenever you see a letter, it just represents a variable. It's something that we don't know. We have no idea what the hours are, so we just leave it as T, and A is the correct answer here. Now I know that someone out there might be wondering, are you going to get a question like this on the test, or will I get something harder than this on the test? I mean, this comes right off the GED study guide, so a question like this is definitely fair game. It comes off the study guide here. Some people might have found this question challenging, and if it's okay if you did. Some people might have found this question simple. So just know on your test, if you've studied and you've prepared well, you should find a mix of easy, medium, and hard difficulty questions. Something like this is fair game. They can ask you something a little bit more complicated like this than this as well. Just depends on the questions you get and which version of the test you get. Okay, the next question says to multiply 2x minus y times 3x plus y. So I'd like you to pause the video, try to figure this out, and then as always, we'll go over it. Okay, hopefully you had a chance to try this out. I'm writing a big word up here, and that word is FOIL. And FOIL stands for first, outer, inner, last. And it's really your guide to getting this question and similar questions right on the test. First, outer, inner, last. So what that means is I want to start with the first numbers here, right? So I've got 2x and 3x, so that's first. So what is 2x times 3x? Well, 2 times 3 is 6. X times x is x squared. So as you'll see here, just by knowing that, we can already eliminate b and d, all right, because we already figured out that the first term is going to be 6x squared. So if you're at a testing situation, honestly, you could probably, if you really were really pressed for time and you got stuck or had to guess on this question, just by doing the first step, you'd already be down to a 50-50. It's either A or C. Whenever you want to guess, whenever you have to guess on the test, you always want to try to eliminate as many bogus answer choices as you can. It just puts the odds in your favor of getting it right. Now, I want you to be able to solve this without guessing, which is why we're going to go over how to do this, but just a little tidbit there about guessing. And what you next do is the outer term. So we did the first. So the outer is, I just go back to that first term and I take the outer term in the second set of parentheses, which is a y, and I want to multiply. So what is 2 times, well, really there's like a little 1 in front of this y. So we're just going to bring that 2 along for the ride. So the answer is going to be 2, then x times y is just going to be xy. All right, and since everything's positive, all positive numbers with this, we would have 2xy. And you might be thinking, well, if I look at the answer choices, how come it's minus xy, minus xy? Well, because that's probably going to change as we proceed throughout the question. All right, so if you're going to try to eliminate something, you probably want to try to do it based off of the f, not the o. All right, now we want to look at the inner. So what are the inner terms here that we are working with here? Well, the inner would be this minus y and the 3x. All right, minus y and the 3x. Okay, so basically, minus y and then the 3x would be negative 1 times 3, which is just negative 3, and y times x is just going to be xy, so it's really going to be minus xy. Okay. And so since the terms are the same, like remember we were just talking about working with like terms here, we've got 2xy and 3xy, the terms are the same, all right, so we can subtract here. And so I'm going to leave that till the end though, but because we want to next deal with the last step here. So the last thing, last just means the two terms that we didn't multiply yet, which would be negative y and positive y. So negative times a positive is going to give me a negative, so I'm going to put a negative right here. And y times y is just going to be y squared. Okay. And so we already kind of know that a is going to be the right answer because it's not 2y squared, it's just y squared. And just know here that we've got 2xy minus 3xy. What is 2 minus 3? 2 minus 3 is going to be negative 1, or in other words, negative xy. All right, so if I were to rewrite this, the final answer would just be 6x squared minus xy, and then minus y squared. Okay. FOIL is an important skill. Hopefully that makes sense to you. Question. A rental company carries tables that seat 2, 4, or 8 people. For a wedding, a customer orders tables that seat 2 people, tables that seat 4 people, and tables that seat 8 people. Which expression represents the number of people who could be seated at the tables that the customer orders? So I'd like you to pause the video, try to work this out, and then we'll go over it. Okay, so a good way to think about this, and first of all, always with a word problem, it's always good to clarify what you're being asked to find. In this case, it's the number of people total, right, who could be seated at all the tables here. Now, if there's a 2-person table, right, and we're assuming that 2 people are sitting there, so let's just say that he buys one 2-person table, and he buys one, or she, whoever it happens to be, the customer orders one 4-person table and one 8-person table. All right, and let's assume the tables are all full. Well, we would just add up 2, 4, and 8, and that would tell us the total number of people. But it's not that simple, right? Because it's not telling us how many 2-person tables he's buying. We don't know how many 4-person tables he's buying or how many 8-person tables. So we are going to have to do a variable here, right? Now, if we knew it was 3 2-person tables, we would do 2 times 3. If we knew the customer was ordering 10 2-person tables, it would be 2 times 10, but we don't know how many 2-person tables he's ordering, so I'm just going to put a variable there, all right? Same with the 4, right? We don't know how many 4-person tables they're ordering, so we just put a letter here, which is y. And I'm using x, y, and z because that's what they use down here in the answer choices. All right, same with 8. We don't know how many 8-person tables he's ordering, or she, whoever the person happens to be, however many 8-person tables they're ordering, so we just put a z there, and so B is the correct answer. Hopefully that makes sense. Okay, so the next question says to add 3 over 6 plus x all over x plus 2. And you have A, B, C, and D, so you know the drill by now. Let's have you pause the video if you'd like to try to figure this out, and then we'll go over it. Okay, so the trick here is you have to know to get a common denominator. Now, I've mentioned this before, but I'll say it again. The denominator is the bottom part of a fraction. The numerator is the top part. So the trick here would be, let's look at our first fraction, 3 over x. And then we want to look at the denominator of the second fraction, which is x plus 2. So what I'm going to do is I'm going to multiply the bottom of the first fraction by x plus 2. And I'm also going to have to do that to the top. And this is actually a really good trick to know throughout the GED that can help you in a lot of cases. But basically, here's what it's going to look like. 3 times x plus 2 all over x times x plus 2. And I'm just going to leave it like this for now. Okay, so now I want to take my second fraction, which is x over x plus 2, and the trick here is that I'm going to multiply the top and the bottom by x. All right, and so the reason why I'm doing that is, again, we need to have a common denominator before we can add anything. So in this case, we're going to multiply the top by x. So here I will solve this out. So x times x is x squared. Now the bottom of the denominator is going to look exactly the same as the denominator in the first fraction. So it's x times x plus 2. So now that I have a common denominator, all I need to do is really just figure out what's going on with the numerator, and we already know that the denominator is probably going to be x times x plus 2. But let's work out the question and let's see. So now I am going to distribute, so I'm going to do 3 times x and also 3 times 2. All right, and so let me show you what's going to happen. And so I'm going to take that x squared, I'm going to rewrite that, I'm going to just change the order of how the additions are going to appear, but it doesn't change the result here. 3 times x is just 3x. What I mean by changing the order, I'm just going to pull this x squared out front here. And then what is 3 times 2? That's going to be 6. Now it's all over x. And you don't really need that parenthesis there, but I just wrote that parenthesis. X times x plus 2. Now we just want to look at our answer choices and see, does this match anything down below? And I think it does. So I think D is our correct answer here. Okay, so next we have a problem that says the quotient of the sum of 4 and 2 times a number and the difference of less than 3 times the same number. And the question says which expression matches that written description. So we're basically going to translate this written description here into math terms, into an expression. A, B, C, or D. So I'd like you to pause the video. As always, try this out and then we'll go over it. Okay, so this is an important question here. Well, really they all are, but this one is really kind of testing you on how well you understand keywords and translating words into math terms. So the first thing I want to point out here that you should know is that the word quotient is a fancy word, but it just represents division, right? So if I did 10 divided by 2, I would say, well, the quotient is 5, okay? And when we see like C and D here, we've got 2 sets of parentheses. Okay, that's actually showing multiplication. So we can rule, I would say we can rule C and D out just based off of the word quotient here, because the word quotient is a keyword for division. And this bar right here in A and the bar right here in B, that is showing us division. So we right away are down to A and B. So if you had to guess on this question just by knowing the second word in the description, you'd be down to a coin flip at 50-50, heads or tails, however you want to look at it. Now the word sum here, it says the quotient of the sum. The word sum, that is a keyword for addition. And my addition sign's a little crooked, but it says that's an addition sign, right? And this would be, see, I hate to write this division sign because this is a division sign, obviously, but really it's kind of this bar that we care about here. I guess there is a bar technically right here, dot, bar, dot, but I'm just saying that when you see this word quotient, you know, look for something with a big bar like this in it, like we see in A and B, more so than this actual division sign. But it says the quotient of the sum of 4 and 2 times a number. Now, whenever you see, so the sum of 4 and 2, so it looks like we're going to be adding 4 and 2, but it says 2 times, so times is a keyword for multiplication. Now multiplication, it's, again, this is kind of like an X, like you write that as like a multiplication symbol, but usually what they'll do for multiplication, it's just going to be something like this, like 2x. So this x represents a variable. It doesn't represent a multiplication, right? So sometimes you'll see something like this, 2 times 4, for example, where the kind of x, this is not really like a variable. This is actually telling you to do 2 times 4, which would be 8, obviously. But you also are probably going to see, if you see something like this, 2 with an x beside it, all right, and then here we see 2 and then an x and then a plus sign, you would need to know that this x here represents a variable. Okay, it doesn't represent multiplication in this case, but anyway, it says the sum of 4 and 2 times a number. So since we don't know what this number is, that's why we would just use an x. And it doesn't have to be an x, you could use A, B, C, or D. But I just want to point out here that what's going on here is we are told the quotient, so we're looking at the top part of our fraction, of the sum of 4. So we're adding 4 to 2 multiplied by some number. We don't know what that number is, so we just put an x. And again, it could be a y, a z, it doesn't matter. Here they just stuck with x. But when you see 2 with a letter beside it, that means 2 times that number. Okay. And then it goes on to say, and the difference of 6 less than 3 times the same number. So one thing I want to point out right away, it says the same number, but it doesn't tell us what that number is. So it's not going to be, you're not going to see an x on the top and a y on the bottom. All right, the variable in both the top and the bottom of our fraction, it's both going to be x because it tells us it's the same number. So it says, and the difference, so difference is usually going to mean subtraction, right? And the difference of 6 less than 3 times the same number. Okay, so you get 6 less than 3 times the same number. So 3 times the same number, all right, it means we're going to start with the 3, and it's 3 times that same number, so that number is going to be x, all right? So whenever you see 6 less than something, that means you want to take that thing, in this case it's 3 times the same number, and subtract 6 just like this. All right, so A is going to be the right answer here. If you got B, you were on the right track. If you got B, I'm guessing probably what you did was you kind of got this part right here where it says 6 less than 3 times the same number. If you got B, you probably misinterpreted or were a little bit confused about what 6 less than 3 times the number means. Because it seems like you would start with, it says 6 less than, so I can see why you would think you'd have to start by writing the 6. And then 6 less than 3 times the same number, but it's really the other way around. You would really start with that 3 times that number and then minus 6 because it's 6 less than 3 times that number. Right, so that's like if I say, well, $5 less than, the $10 I started with or something like that, you'd want to start with the $10 and then subtract 5. If that confused you even more, then, please disregard that. But A is the correct answer here. Hopefully this makes sense. Okay, the next question says, Lucy is shipping 5 boxes that all weigh the same and 1 envelope that weighs 7.5 pounds. The total weight of the shipment is 65 pounds. What is the weight in pounds of each box? Okay, so you know the drill by now. You could pause the video, try this out, and then we'll go over it. Okay, so basically what we're going to do here is we're going to write an equation, and we know that there are 5 boxes here, right? They all weigh the same thing, but we don't know what one box weighs. So let me write x here, because x is going to be our variable, since we don't know what one box weighs, but we know that it would be 5, the number of boxes, times the weight of one box, all right, plus, and that's a plus sign, plus it says the one envelope weighs 7.5 pounds, so plus that 7.5 pounds for the envelope, all right, and this is all equal to the total weight, which it gives us 65 pounds. So I'm just writing an equation here. All right, so again, let me recap what I've done here. It tells us the total weight of the shipment is 65 pounds. So from that, you kind of work backwards and think, well, how would I calculate, what would I have to know to get that 65? Okay, if I didn't know the 65, well, I know that there's 5 boxes. I'd have to know what the weight of one box is, since they all weigh the same. And I'd multiply that by 5, and then I'd add to it the weight of the envelope. That would give me the total. All right, that's how we would find the total, but in this case, they've given us that total, so from that total, and we know what the weight of the envelope is, and we know there's 5 boxes, we can work backwards to isolate this x. If we solve the equation for x, if we get this x by itself on one side of the equation, all right, what that's going to do is that's going to tell us exactly what we need to know. It's going to give us the weight of one box, or the weight in pounds of each box. 2 ways of saying the same thing. So what I'm going to do first is I'm going to get rid of this 7.5, okay, because we want to get that x alone by itself on one side of the equation. So let me, since it's 5x plus 7.5, the opposite of addition is subtraction. Whatever you do to one side, you always do to the other. So 65 minus 7.5 gives me 57.5. So let me rewrite this thing down here with what we've got now. So we'll have 5x equals 57.5. So now, again, we're trying to get this x by itself. We want to isolate that variable. And the reason we're doing that is because when we figure out what x is, that's going to tell us the weight in pounds of each box. Since it's 5 times x, how do we get rid of that 5 so we can have the x left by itself? We have to divide, because division is the opposite of multiplication. You could also say it's the reciprocal or the inverse, a bunch of fancy words meaning the same thing. But basically, I'm going to divide by 5 on both sides. And if I do that, 5 divided by 5 is just 1. 1 times x is just x. So we've got x now. 57.5 divided by 5 is 11.5. And bingo, B is our correct answer here. Hopefully that makes sense. Okay, so the next question is a systems of equation. It shows you've got 4x plus 3y equals 8 and 4x minus 3y equals negative 16. And it says, what is the value of x? So you can pause the video, try this out, and then as always, we'll go over it. Okay, so system of equations questions actually strike fear into the heart of a lot of students. So if you're not sure how to do questions like this or they're really tricky for you, don't worry because we're going to go through how to do it now. There's actually a super quick shortcut I see that we could probably solve this in seconds, but it's not always going to work out that nicely on the test. So let me show you the straightforward way that's pretty much, if you do it the right way, guaranteed to get you the right answer. It's just going to take, it's just a little more tedious, but this is, you know, I'll show you the shortcut after, but I don't want to show you the shortcut up front because they're not all the questions. In fact, most of them are not going to hand you the, you know, they've really given you a gift. Let me say this. They've given you a gift by the way that they set this question up here. I don't know if they're going to hand you a gift like that on the real test. So let's first start with the basic foundational skill of how to solve this question out. And then after that, I will show you that shortcut. But again, I wouldn't count on them handing you a gift like this on the real test. And if you're saying, Parker, this question is confusing, there's a gift, they've given you a gift, what do you mean by that? Just stick around and I will show you the trick too. But again, it's not always going to work on every question like nicely like this. So that's why I don't want to show you the shortcut because I don't want to, you know, misrepresent how confusing these questions can be. So let's take the confusion out of it and let's solve it the more straightforward way first. So first of all, we have to clarify here that the value, what they're trying to find, they want us to find the value of x. So let's call this first equation equation 1, and let's call the second equation 2. And I want to pick either one. Usually you'd want to pick the equation that is the simplest looking. They're both equally kind of complicated here, so there's not really, you know, there's none of them are really, I wouldn't say either is simpler than the other, so we'll just pick equation 1 just to start somewhere. And what I want to do is I want to solve that equation for y. Well, why do I want to solve it for y? Well, because it's ultimately asking us for the value of x. All right, so system of equations question again, you want to pick either equation 1 or 2. It does not matter which one you start with. I'm just starting with equation 1 here just to start somewhere. But you don't have to do that necessarily. And then you want to think, what's it asking me to find? It's asking me to find the value of y. All right, so, or I'm sorry, it's asking me to find the value of x. But here we want to start by solving the equation for y. And you might be saying, well, how's that going to help us? Well, you'll see how it's going to help us in just a few seconds here. I mean, if you solve the first equation for x, you still can get the right, you'll still get the right answer eventually. It's just it's a little bit more, there's an extra step if you do it that way. So that's why I say, you know, pick an equation, solve it for the opposite variable of what they're asking you to find. So again, I know it probably sounds like I'm, you know, getting you more confused here, but again, I just want to make sure you really understand the foundational principle here of what we're trying to do. We want to pick any equation and we want to recognize it's telling us what is the value of x. All right, in order to get that value of x, we have to start by picking an equation and solving it for the other variable. We want to solve, so we pick equation 1, we want to solve it for y. All right, and then we're going to take that y and we're going to plug it in to the second equation and it's going to spit out the value of x. All right, again, if you start by solving the first equation for x, then once you plug that x into the second equation, you're going to get the value of y. So you'll know the value of y and you'll have to plug that back in to get the value of x. And it's an added step. So that's why we're doing it this way. So I want to solve this equation for y. And the way I'm going to do that is just like we always would. We want to get the y by itself on one side of the equation. So I have 4x plus 3y. I want to get rid of the 4x, so I need to subtract it from both sides of the equation, which will leave me with 3y equals 8 minus 4x. And I really want you to see the matrix here, so to speak. I really want you to understand this. And I know I'm repeating myself, and I know this might sound tedious, but it is really important because these questions are really confusing for a lot of people, and it doesn't have to be that complicated. And once you understand how to get this, it's something that within a minute or two, you'll probably be able to figure it out on your test. And I want you to get the most points that you can, because it's frustrating. It takes a lot of time for people to have to keep redoing these tests over and over again. It's stressful for everybody, not just you, for your family and those around you, to have to keep paying for practice tests and stuff over and over and over again. So I know that sometimes it's tedious, and I spend forever explaining questions, but it's because a lot of people sometimes they'll comment and they'll say, oh, like it took you forever to explain this, blah, 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 blah. Well, the reason I'm doing that is because it's not here to just, waste your time. It's because I really want you to get this on a deeper level so you can get your test done, hopefully on your first try, or if you've already tried before, hopefully as soon as possible so you can move forward. And again, what I did was I solved for y here, so I had to divide by 3 on both sides, and I found that y equals 8 minus 4x divided by 3. So I'm halfway done. So congratulations if you followed me this far. We got to the halfway point of the question, because now what I want to do is go back into this equation 2, and I'm going to replace y with 8 minus 4x divided by 3. So I'm going to take my y, and I'm going to go into the second equation, and I'm going to substitute 8 minus 4x divided by 3 in for y. And I can already see here this is going to work out really nicely, because it's it'll be 3 times 8 minus 4x divided by 3. So the 3's are going to cancel out. So I can already see that. And I know, again, like I said, I take a long time to explain things sometimes because, I really want you to see the matrix. I really want you to get this on a deeper level because, you'll get to the point where you can already see things. You can be a couple steps ahead of the problem. You can be a couple steps ahead of what the test writers are asking you to do. And it's not going to happen right away, especially right now if you find yourself struggling. But just the way right now I was able to see, okay, there's a 3 down here. We're going to be multiplying by 3. We're going to be able to cancel that out. You'll get that kind of vision too. If you really understand math and really understand what's going on, you'll be able to see things like that too. And that's really how you're going to pass or get a really high score. Because right now we've got 4x minus 3 times 8 minus 4x divided by 3. Now, you could take this 3 and distribute it, right, and multiply it by 8, and then multiply, or negative 3 times 8, negative 3 times negative 4x. You could do that, but it's kind of going to take up too much time because we can also just cancel these 3's out right here. And that's just what I mean about kind of developing the vision to kind of see what's going on ahead of time. And also here, let's see, so here's what we're going to do now. We need to get this x by itself. And so now what we're going to do is we still have to take this negative sign, right? Because it's 3 divided by 3, so there's still technically a negative 1 here. So we do have to distribute that negative sign, but it's a lot easier than bringing the negative sign and the 3 along for the ride. So negative 1, which is what we're left with here, times 8 is going to be negative 8. Then this is going to become plus 4x. All right, so let me rewrite this up here. We've got 4x minus 8. And I'm just trying to squeeze this all in, so that's a little minus sign. And now it's plus another 4x equals negative 16. And this is a lot easier to work with already. So 4x plus 4x, they're both like terms, so we can add them. 4x plus 4x just gives me 8x. And at the same time, I've got a minus 8 right here. So I can add 8 to both sides of the equation, and if I add 8 to both sides of the equation, I'm doing negative 16 plus 8, which is going to be another negative 8. So now I'm left with 8x equals negative 8. I just divide by 8 on both sides, and I've now found x. And x equals negative 1, okay? And again, hopefully this is making sense now why we did it this way. So let me just recap, because this is confusing for a lot of people. So if you're having trouble following this, it's not just you, don't take it personally, because these are tricky, but once people get this, they really get it and it sticks for them. It helps them understand other questions too, not just how to do these one questions. So again, we pick one of the 2 equations, it doesn't matter which one. I picked one just to start somewhere. And then it says, what's the value of x? So counterintuitively, I want to start by taking that equation that I picked and I want to rearrange it and solve it for y. Then once I get the value of y, which we did here, where I had y equals 8 minus 4x over 3, I took the y that I found for and I plugged it into the second equation down here. All right, and that gets me down to one variable. And that's really the idea here, is you don't want to be working with an x and a y. You want to just be working with one or the other. And what I'm trying to emphasize here is that if you kind of understand what's going on and understand math, which it's easier said than done, it'll come with time, but you can kind of look ahead a little bit and think about this when you go to make a decision. I take this first equation. Do I want to start by solving it for x or solving it for y? Well, the reason, again, you solve it for y first so that you can take that y, plug it back into the second equation, and then you'll be down to just one variable. You'll be left with just x, and you just solve the problem all the way through, and you find what x is, and you're done. Okay, and I know it's easier said than done, and I'm erasing this because I'm going to show you the shortcut method here. And sorry if I seem like I'm oversimplifying this, but I'd recommend, if you have a lot of trouble with this, you can watch another video or two on my channel, because it's one of those things, it's hard to get at first, but once you get it, I think it usually sticks with people. But let me show you the shorter cut method here. And now hopefully you can appreciate the shorter method to do this. And it's not always going to work out this nicely, but here what they've done, they've given you 4x plus 3y and 4x minus 3y. So really if I just, and let me show you, this can be done in seconds. If I add both equations up here, so let's do, what's 4x plus 4x? Well, the answer is 8x. Now I've got plus 3y minus 3y. Uh-oh, they cancel out. I shouldn't say uh-oh, I should be glad. They cancel out. Now what's about, if we add 8 to negative 16, in other words, we do 8 minus 16, that's going to be negative 8. And look where we're at already. 8x equals negative 8. I just divide by 8 on both sides. 8 divided by 8 is 1, which just spits out the x. 8 divided by negative 8 equals negative 1. Voila, just like that, that fast, we spit out the answer as being negative 1. But I didn't want to show you that at first because this is really a gift here. I don't know why this is like a really, really big shortcut here to doing this. And the shortcut, again, it occurred because we've got two equations here, and you've got 4x plus 3y, 4x minus 3y. So whenever you see a number and a variable that appears, if it's the same number and the same variable in both equations, and they've got opposite signs in front of them, meaning, the first equation, if you've got a plus sign and then 3y, the second equation, you've got a minus sign and 3y. If that happens, you can just add them up just like I did, because these are going to cancel out, and then you can just solve it for that x, just like that. Okay, so alternatively, you can set the question up, like if it said to solve for y, like you can set the question up that way yourself, if they don't give you a gift like this, where they've set it up so that the terms are going to cancel out. In that case, what you would do, like let's say I wanted to use the shortcut method and I wanted to cancel out the x's. Well, what I would have to do, because this is really positive 4x and positive 4x, so I could say, well, let me take equation 1, for example, and let me multiply this by negative 1. Now watch what's going to happen. If I multiply this by negative 1, okay, what's going to happen is I would have minus 4x plus, or no, it won't be plus anymore, it's going to be minus 3y. Oops, I'm all over the place, equals 8. And then in the second equation, I have 4x minus 3y. Why did I leave this as 8? This is going to be negative 8, because every single term here gets multiplied by negative 1. Okay. And so basically, see, I left the second equation as it is, but the first equation, all I did was I multiplied everything in the first equation by negative 1. And the reason I did that is because now if we try to add the two equations, we've got negative 4x plus 4x, that's going to cancel out. And you still have to do, negative 3y, plus negative 3y, or you can just think of it as negative 3y minus 3y, okay? And it's going to give you, what's that going to be, minus 6y equals, and you've got, negative 8 and negative 16, okay? And that's going to, I don't want to solve the whole question out here and take too much time, but I'm just showing here basically you would be getting this down to just one variable, which is really the key here. And so if this confused you even further, then don't worry about it, but just note that, here they've given you that shortcut, and again, the reason is you have to understand it's because the goal here is to get just one variable. You don't want to work with two variables. If we've got an x and a y, that's two variables. You just want everything in x's or everything in y's. And in this case, they've given you plus 3y minus 3y. You add the equations, the y's are going to cancel out. If for some reason, like I wanted to solve it for y, then you could take the x's. You just have to get it so that, you've got 4x and then minus 4x. Or you just have to get the two x's to match the same number but opposite signs, meaning one's positive, one's negative. You can add the equations up and cancel it that way out, all right? So Unfortunately, there's not really, I would say probably, unless they give you a case just like this on the test, you're probably better off just doing it the first way I showed you. It's just tedious. And if you're really struggling with this and you've watched a couple videos on this already, or you've put some time into this and you're just not getting it, I wouldn't lose sleep over it. It's probably going to be one question, maybe two at most on your test. But then again, every question you can get right is going to count. So again, it's one of those things you put some time in. For a lot of people, it's hard at first, and after you see a couple examples explained, a lot of people start to get it. But if that's just not working for you, it's okay. It's just one topic on the test. Okay, so this question says, Isabella saved $1,500 or $15,000 and bought a car that cost $12,700. The insurance for the car will cost $600 a year. How many full years will she be able to pay for car insurance with her remaining savings? So I'd like you to pause the video as always and try this out, and then we'll go over it. Okay, so let's go over the question here, but I just want to point out here that on the study guide, they have this labeled as an example of solving inequalities and graphing the answer on a number line. And I'm kind of scratching my head because I don't see how this involves inequalities, and I certainly don't see why you would put anything on a number line to solve this question, but that's what it says in the guide, and I'm going to show you really how you would solve this question, and unless I'm just losing my mind here, I don't see how this involves an inequality or especially how this involves a number line. But hey, if anyone has any idea as to why that is, other than maybe they just mislabeled it in the guide, I don't know, please let me know down below by all means. But here's how you would get the right answer here. You just figure, okay, she starts with, she starts with 15,000, and then she spends 12,700 on a car. And how much would she have left after that? She'd have 2,300 left after that. And now the insurance for the car, it's going to cost $600 a year. How many full years will she be able to pay for this? Well, all you're going to do now is take this 2,300 and divide it by 600. Okay, and what's that going to give us? Well, in my calculator, I get 3.833333, a bunch of threes repeating here. And since it says how many full years will she be able to pay for it, this number would round up to 4, but then again, if that's, all she can afford is 3.83 years, just because the number rounds up to 4, that's not really the point here. The point here is to figure out how many full years she can afford. She can't quite afford 4 years, so just keep that in mind if you picked B here. You might have been thinking, well, 3.83, that rounds up to 4. It's correct that that does round up to 4, so I like the thought process, but you also have to consider that, if she can only afford for 3.83 years, she can't quite afford 4 full years. So just because this number does round up to 4, I like the thought process, but that doesn't necessarily, she can't necessarily afford the full 4 years. So that's why you would actually have to really think, well, 3.83, that means she can afford at least 3 full years and a little bit more, but not quite 4 full years. So that's, you would just have to know that 3 is the right answer here. And on the study guide, 3 is the right answer, so to me it just seems, I know this isn't all going to fit on the screen here, but I'm just a little bit baffled as to why they have this labeled as solve inequalities and graph the answer on a number line, because it seems to me just take the 1,500 or 15,000, subtract 12,700 and divide by 600, and then you just have to realize, it's a little bit over 3 years, but if we're, answering in terms of the number of full years, you would have to say 3. A is the right answer. Again, I'm not sure why this is labeled that way, but that's, that's how they labeled it on the study guide. Let me know if you have any thoughts on that down below. I'd love to hear somebody else's thoughts on that. We still have a lot of really important things that we didn't talk about yet that are in the study guide that are really going to help you pass the test or do better than passing and get your goal score, whatever that happens to be. So I hope you'll join us over on part 3. When it's done, I'll have the link down in the description as well as here in the video. Regardless, thank you so much for watching and good luck on your test.